of 8 p.m. and excuse me. Um, yeah. Um, first, I mean, okay, people will slowly come in, I guess. This is my first time, so I don't have any prior experience to going live. This is my first YouTube live. Um, okay, I would like to start by introducing this channel. It's a very young channel. It's just been a little bit more than a month, and thanks to your love and support that we got 1,000 subscription within a 45 days. Um, this channel is about the science in general. Uh, so it's basically science popularization, you can say in some sense, uh, but also a perspective into science and society from a person who is in the field for a long time. I have been working in this field quite for some time, uh, more than 15 years. It's been already been. So, so I would like to give you a test. Uh, how does it feel like to be an astronomer? And if you want to, some of you may want to become uh, an astronomer, astrophysics in the future. So what should you expect? So things like that, or if you want to go to grad school, and that means if you want to do PhD in astronomy or astrophysics, what do you have to do? Like applying in abroad in Europe or in the US. What are the steps you should take? Um, what is research? How do you do it? And how do you write papers? These are the things that I would like to talk today. I may not uh, be in one specific topic, but I will try to sort of give you an overview of the field and um, how it feels to be an astronomer, astrophysicist, and also I would love to take your questions if there are any questions. So yeah, this is quite a short introduction for the channel and about the program today. Once again, if there are any questions, you can interrupt me and post your questions. Um, so, talking about astronomy or astrophysics these days, I think this is one of the exciting um, period in astronomy, astrophysics. We have a tremendous leap in the development of instruments, space instruments, ground-based instruments. We have gamma ray telescopes, X-ray telescopes, many optical telescopes in space, and there are huge and large telescopes on ground, um, and we have now um the optical is kind of considered to be the traditional um, way of doing astronomy, but now we have two new types of instruments, or not quite electromagnetic detectors. Um, we have now gravitational waves. Um, what gravitational wave means is you can hear the sound in space time. This is this is quite an achievement for us. For us, and on top of that, we have neutrino detectors. A couple of neutrino detectors which detect neutrino from faraway universe. You might know that neutrinos are also known as ghostly particles because they barely interact with matter, so they can easily pass through the matter, um, and the Earth, so without being detectable. So the idea is that some of the neutrinos from right after Big Bang, maybe we can see them, and we can detect them. Uh, so this is, so I was saying that this is very exciting period in astronomy, that we have all kinds of instruments, space telescopes, optical telescopes, neutrino and gravitational wave detectors. With all of these instruments we have, we can get a comprehensive view of the universe. Um, the question that are already there: how the universe began, how will it evolve, how it is expanding, what are the procedures, what are the important forces at play, what are the particles. These are the burning questions of this period, and with all of these instruments, astronomical instruments, it plays a very important role to find the basic nature of the universe. um, so then I mostly work on something called active galactic nuclei, which are the central cores of the galaxies, and these are powered by supermassive black holes, which are billion times massive than the sun itself. You can imagine the billions of sun are packed in a small region as small as the solar system. The whole black hole resides there, and the matter swirling around in the form of accretion disk, and this will increase the temperature of the disks millions of degrees. And it is interesting to know that the some of the biggest black holes are actually the brightest source in the universe. Uh, so on top of that, this active galactic nuclei may eject jets which travel nearly at the speed of light, and that these jets, you can easily see from radio telescopes. You can see the images, uh, and the question would be how the environment near that supermassive black hole would look like. The intense gravity, the highest temperature, and the highest speeds that you see in the jets. Uh, so to understand, to study about this active galactic nuclei, um, so looking through one telescope or optical telescope is not enough, because it only gives information in a small band of the whole electromagnetic spectrum. Remember that uh, the excuse me. Uh, okay. Um, Sorry, that was. um, I was saying that the the electromagnetic wave is a very broad band, and the optical is a tiny part. The optical that you our eyes is sensitive is a very tiny part. All right, and below. Uh, sorry about that. Someone. Uh, and the uh, so so the longer wavelength would be infrared and radio waves, the kind of microwaves we heat our food, or cell phone, mainly based in radio waves, uh, and the higher or shorter wavelength or higher energy wavelength would be ultraviolet, which is thought to be dangerous for our skin, um, and then X-ray. X-ray is even dangerous. We use to see through our body, basically to see our bones in the So you can say that these are very energetic particles, X-rays, and which can pass through the flesh. So you can see it in flesh on our body, it's just the bones, and even higher energy particles are gamma rays, right? The gamma ray is even more powerful. Even a short exposure gamma ray on our body could be, cells can quickly die, and there can be a serious rupture in our cells. So very dangerous. But in an Asian emits all those lights, right from radio to infrared and optical and ultraviolet and then X-rays and gamma ray. So in a wide spectrum. So it is not enough um, to study using optical telescope. For that, we need other telescopes. Actually, of course, the one of the cheapest method and easy method is radio waves. Um, I yes. Academia Prosody is saying cosmic rays. Yes, you're very right. So uh, I can spend the entire session on the cosmic rays, but it is very important point, the cosmic rays. Thank you, Academia Prosody. Um, these jets from Asian also accelerate. These are basically accelerate particle accelerators. um, the particle accelerators on Earth, basically, CERN, can accelerate particles up to 10 to the power 13 eV. That's how I measure this electron volt. Probably some of you know, but some of you not. That's the unit of the energy that the particle gets after being accelerated. 10 to the power um 13, 10 to the power. But these Asian jets can produce the cosmic rays, the particles, up to 10 to the power 21. So kinds of seven order higher than what our current technology can achieve on Earth. That's basically CERN. Yeah, CERN is particle accelerators. Um, yes, the Asians also uh, um, um, produce the cosmic rays. Vivek Yadav says Namaste, sir. So Namaste, Vivekji. Thank you for joining. Um, so um, so to study, so the current question would be, how would uh, a black hole, supermassive black hole, that's billion times more massive a sun operates? Yeah, and how the accretion disk would be, and what mechanism would launch these jets that can accelerate the particle up to 10 to the power 20 eV. Also, when you talk about the cosmic rays, maybe I want to a little bit talk about this, how we know the energy of this particle and how do we detect cosmic rays, right? So the cosmic what are cosmic rays? Cosmic rays come from faraway space, mostly from supernovas or active galactic nuclei, basically the black hole systems. you know uh, Once again, the black holes, if they are isolated, they don't do anything, they just sit quietly there. But the moment they find a companion, uh, or any if any stars or planet passes by the black hole, then it kind of tears or stills the matter from the companion, from the star, and it can destroy the star or the planets nearby, and it stills the matter, and it's very accelerated towards inward, yeah, very swirls around the black hole. And in that process, as I mentioned earlier, there's a lot of friction. Yes, this friction will hit the particle, uh, and it will the temperature of this accretion disk, the matter going around the black hole, will tremendously rise, like millions of thousands and millions of degrees. That's what I mean when the the black holes are maybe the brightest objects, apparently black, but because once they have matter around, then this temperature increases very high. I can see some chat. um, uh, so Vivek Yadav ji says, can you share how your day, month, year, or life is like an astrophysicist? Uh, so if I'm not mistaken, you're asking how do I pass my day? If you're asked my daily life, if not, let me know. So being an astrophysicist, astronomer these days is, as I said, is very exciting. But now there are so many elements. Yes, so many things you have to know. Again, I just explained that uh, we study we now the astronomy is called multi-messenger astronomy, right? So okay, thank you for clarification. Yes, I'm talking about the your daily life. That's Vivek says. Okay, so we have a multi-messenger astronomy these days. What is a multi-messenger? Well, electromagnetic waves, which is like our traditional telescopes from the ground, and radio waves, radio telescopes like dishes, and some space telescopes, X-ray and gamma ray. Remember, we can't have X-ray detector on ground because our atmosphere is opaque for X-rays and gamma ray. They cannot come through the atmosphere, right? So these are these are our um, electromagnetic messengers. Okay, and but now we have neutrino and gravitational wave. These are different from the electromagnetic waves. These are not electromagnetic wave. So like a Virgo thing, they detect the gravitational wave, and then neutrino detectors, ice cube and these things. So these are different from, and this detector work differently. And somebody already pointed out, academia prosody pointed out cosmic ray detector. So to understand astrophysics is basically understanding how an astrophysical system works. What is an astrophysical system? Could be galaxy, could be black hole, could be supernova. So how does that's what we do. So to understand, you have to know multi-messengers. Yes. Uh, so only being optical astronomer is not enough these days. You can say that, okay, I cannot, I will only specialize these things. Of course, there are some people who specialize on the detectors. Like there has to be some people who have to design the telescopes. Yes, they can spend that. But if you want to be an astrophysicist these days, uh, um, it becomes kind of necessity that you know a little bit of these things. So you have to read a lot of papers. You have to know about how a gravitational wave detector works, neutrino works. What are neutrino? How are neutrinos produced, and what is gamma ray, and how they are. So it's a lot of work. Well, if you don't, any not in astronomy, in everywhere else. If you enjoy something, then it doesn't feel like much. But if you don't enjoy it, it brings a lot. So because I enjoy, so although I have to do a lot of work, so know about all this kind of telescopes, uh, and then uh, you have to write papers, right? As an astrophysicist, this is our main job. At the end of the day, you want to do research, and then you want to publish and then show the world that what you found. So this is one of the important part of the life part of the life of an astrophysicist. And go to conferences. Hopefully, I will see you guys in one of those conferences and meet people. Uh, and there's one important aspect of modern astrophysicist. Uh, Back in those days, you might have watched a movie. That there's one of those crazy scientists working in the laboratory alone, right? Mixing different kind of chemicals. Or we even hear about Einstein, who basically worked alone. Newton, there was some kind of pandemic, there was nothing to do, and he produced the theory of gravitation, right? These are the pictures when you say the scientists, but this is basically no longer possible these days, um, because people have to work in teams, like a large team. So, for example, the Cosmic Ray Telescope team has 500 or 1,000 uh, scientists working for them. The LIGO Virgo is about thousands, 2,000, 3,000 people are working. So these days, it is not possible to be a scientist working alone. Uh, of course, it could be a theoretical work, but most of the work it has been already done. So either you're very genius to be working alone, otherwise there's always a large team. So meetings with colleagues, uh, conferences, and writing papers, analyzing data, and working with students. So these are the part of my life as an astrophysicist. Are there any questions? Okay. Let me know if you have. So yeah, there's another question. New way of so Academia Prosody says new way of detecting low frequency gravitational waves using pulsars is way more better than gravitational waves detected on Earthlight. Uh, this is a very very important point. I think there is the PTA is doing pulsar timing array. This is dedicated team to do that. So I can give you example what it's for the other people. So what Academia is saying that um, so to detect gravitational wave, we have a Virgo LIGO telescopes, right? Uh, Probably you are familiar how it works. The light and they're very sensitive instruments. If the slightest disturbance is detected, there's a mirror, and which one was going this way, the other go this way, and then they come back and interfere, and basically interference patterns observed. And this is very very difficult task because the gravitational wave the could be order of the way smaller than the diameter of the proton. It's very difficult task, and people started the collaborations back in 70s along. It's been a long long time. Excuse me. Okay. Um, and then uh, so and it's also costly. You remember they started the collaboration in 70s, and they produced the result in 2015. Their one concrete was concrete result for 2015. So your meaning is right. How much hard work it is. So he's suggesting that may the pulsar using pulsars to detect gravitational wave is could be far more better and easier way. Um, and the technique is the method is that let's say there are boats. Okay, boats. There's, imagine there's a lake. Okay, and there are boats, and four, five, six, seven, or tens of boats there, and um, they have a lamppost, some kind of right. A lake filled with, let's say, 20 boats, and the boats have lamppost, some kind of lamp. Yeah, and um, now you start the water. Let's say there's some disturbance in the water. What will happen? Um, some boats in some part will, because they have lamppost. Yes, you can also imagine it's night. Some kind of some will, so you'll see the variation in the light in different parts, right? Because the water is disturbed in various part of the region differently. So some of them will go up because the wave or water, some boat will go up, some down, so there will be disturbance. And watching um, those waves, right, the lampposts uh, on the boat will actually tell what kind of disturbance it is. So in this case, the gravitational wave is in the form of the disturbance in the water. Um, this is the technique for pulsar timing array. That's PTA. So using, so now we have to go back to what is pulsar in the first place. Okay. Um, here's I can see some of the Suresh say we encourage all viewers to post their questions, if any, without any hesitation. Of course, I encourage you all to ask, um, post your questions. And he further adds, Suresh, you further add, also invite your friends if they have any questions to him. Use the power of social media. Yeah, that would be great. I mean, you can, because you have a cell phone basically. Any your friend or somebody who is interested, keen on astrophysics, you can call him or send message right now and ask them to join the live. That would be, thank you, Sureshji. Then we have another comment by Drishant Maharjan. Hi, Drishantji. Hi, sir. I'm currently a student hoping to pursue astrophysics in future. What you say in current day are the foundational skills are crucial for someone entering the field. Yeah, this is exactly the topic of my presentation today, being live. Um, I can tell you, being in the field, what we should expect and how to get to the grad schools, how to submit your PhD publications. Sorry, no, PhD applications in USA or Europe. I will answer you. Let me finish this topic, and then I'll come to you, Drishant Maharjan ji. So, um, pulsars, yeah. So it all started with that we can use pulsars for gravitational wave detectors. So what are pulsars? um, Pulsars are the cosmic clock, you can say. Okay. You know, they they very periodically appear in sky, meaning you can see like tick tick, this is a blink of light. So well in time, in period. That's why it's cl- called clock. Yeah, the cosmic clocks. So to understand physics, you might have heard something about the life cycles of the stars. Even the stars someday die. Yes. And when they, at the ending phase or the late phase of the stars, they explode immensely with supernova, and what remains is the very compact core of the mass in the form of neutron stars. And this neutron star, because happen from the clumping of the matter, they also have the magnetic fields, and it might happen that the alignment of the magnetic field is different from their rotation, excuse me, rotational speed. These neutron stars are rotate very fast in millisecond. The period is second, millisecond. And if that magnetic field alignment, like magnetic northern pole, is different from their polar axis, northern, polar, and then there's a jet, and then you can periodically see the light if that faces toward the Earth. So these are pulsars. Yes, they were discovered in 50s. Um, and now the point is that we have in our galaxy there are lots of um, um, excuse me, I've been receiving messages a lot. Okay. So how can now exploit this thing? So there are pulsars distributed all in um, our galaxy, mainly galaxy. Okay, we actually cannot see many pulsars uh, in extragalactic other galaxies. Why? Because the pulsars are mainly very small systems, like the radius is 50 kilometer. So it's hardly nearly very difficult to see the pulsars in other galaxies. But in our galaxy, there's a lots of distribution of the pulsars now. Now let's say that from far away, somewhere, or in our galaxy or in some other galaxies, there's a collision of the two neutron stars or black holes and producing a gravitational wave. That is basically the gravitational wave. Is what is gravitational is a disturbance in space and time. Yes. Something like I compare a lake is full of water, and on them there are boats, and the if there's no disturbance, the lake is quiet. But if you disturb it, then the waves propagate, and these waves are like sound sounds in space and time. And if there's a gravitational wave propagating in our through our galaxy, then because we know the exact timing of these pulsars, yeah, because of these gravitational wave, then we can see slight change, and that slight change will tell you about the gravitational waves, the nature of gravity. So that is the idea behind. But um, it is not so simple as it sounds, because those order of fluctuation between different pulsars is so tiny that our current technology may be not possible. Also, there are dedicated team, yes, pulsar timing array to do this kind of things. But I'm not aware of any major results. But yeah, this is one of the important way to detect the gravitational wave. All right. Coming back to Drishant Maharjan, so he wants to be an astrophysicist in future. So what does he have to do? What skills require? Uh, uh, okay, this is a question. This is actually about this live session. So I would like to encourage all young people out there to fulfill your dreams to be in astrophysics, astronomy, to know about the universe, to know about the matter, and ultimately themselves. So, okay, what do you have to do? The so as I mentioned you earlier, doing astrophysics, astronomy has become very exciting at the same time difficult these days. Why? Because there are so many things you have to do. You have to know and you have to do. But they are very encouraging that all the data are by the space telescopes uh, or ground-based telescopes. Everything is probably publicly available. So you can start by analyzing and looking into any sets of data. Um, so the best way to go is you have to get into research, right? And how to analyze astrophysical data. We have to start from somewhere. You can X-ray, gamma ray, or optical. There are lots and lots of publicly available data, uh, and now you have to know the softwares and tools and Pythons and program on, because uh, this space and telescopes data are basically in the forms of uh, some computer binaries, and should know how to process them. Yes. So you would need the tools to analyze this data. So if you want to come to my field, which is high energy astrophysics, then there are a couple of tools like HereSoft, high energies, and there are Fermi tools, there's X-ray tools, and things like that. You should know this kind of. You should start learning this kind of things, and you should frequently read the papers, of course. But you also have to learn how to write the papers. Um, there are lots of people in Nepal. So I am also working on with. If you're from Nepal, I assume by your last name Maharjan, you could be Nepali. Yes. So we are also some team. I'm also working with students. You're welcome to join us. Having being said that, I sometimes I'm late because I'm doing too many things, but I definitely welcome you. There are other people also. For example, Suresh is um actively um, involved in promoting astronomy in Nepal through different programs. So you can also suggest. But yeah, that's the way. So you should know some skill, right? Start analyzing some data, some form of data, X-rays and gamma rays, or um, optical, and you should learn Python. The program is very important now. Machine learning has come, right? um, so which it's had become a part of our life. So and this is the widely used in our analysis. So computational power, learn Python, um, machine learning. But again, you would need, why do you need that? So some form of data, some data analysis would be the best for you to start with. And then you need to know how to write papers, overleaf, creating draft, and LaTeX, which basically well, if you know overleaf, you probably don't need to know about the LaTeX, because that's included in these days in overleaf. So start making teams, start working with people. You're welcome to send me email or something. I can help you also. Um, okay, I hope I answered your question, Drishant Marjan. Um, then and Shashwat SR says love emoji. Thank you very much. Um, so if are there any other question? I would love to take your questions. Um, or then, okay, Osis Nirola. I hope I pronounced your name correctly. Does aerospace engineer could cover topics related deeply with astronomy? Yes, of course. Uh, so now this is another important aspect now. Um, Dishant Martin says, absolutely, thank you so much, sir. Thank you, Dishant. Um, Now, we're coming back to Oasis. Aerospace engineer course cover topics related deeply. Yes, I mean, uh, these days things are intertwined. Yes, one thing is related to another. The space thing is a future. Yes, you can look at it in two ways. One of the ways is to explore the universe. The other is that we will have to go to space someday. Yes, we call it space tourism, or for survival purpose. Someday we'll have to leave Earth, but that's very far away. But space is the future, and uh, the we will need manpower, working on um, space, for tourism or other purpose, for telescopes also. Uh, and there's another thing also now that we seem to be also developing the space garbage. Lots of garbage have been produced in space, and the cleaning them is would be one of the challenge. And again, uh, uh, the one thing is very much related with other thing, and the lights, the electromagnetic wave, the X-rays and the gamma rays. Some pretty much in astronomy is very much related into aerospace, and then orbits, of course, the orbits, the physics. So yeah, I would say that it's pretty much related with astronomy. Again, there's a slight difference between the astronomy and astrophysics, in the sense that geography and geology. So you will need to know astronomy rather than astrophysics if you want to be aerospace engineer. Um, yeah. I mean, the engineers are everywhere. There are huge detectors being built on the cosmic rays for radio or other things. They will need engineers, and as I said, there will be space instruments, and they will require aerospace engineers. And yes, that's pretty much related, I'll say. So Academy Apprentices, I have a question about time. What exactly is time? It is just the measurement or aging. Why should the change in speed of time effect of time dilations? Well, very good question. I mean, this is very philosophical also, and very, it's a deep question also. Like, what is time? Uh, well, and and how this time dilation affects kind of thing. Well, historically, time and space were thought to be very independent, right? I mean, what that means is 1 hour in one part of the space or here is the same as 1 hour is the same length of 1 hour in any part of the universe. So it doesn't matter where you go. 1 hour, the length of 1 hour would be is the same. Uh, but that's and but slowly, so Einstein came in the picture, and he said no, space and time are linked. And what is the link is the speed of light. What is the speed of light? Is the speed of the maximum speed the information can propagate, yes, from one place to another. Things cannot um, propagate in inverse uh, uh, faster than speed of light. So this is the one way of tying, tying space and time, because 1 second speed of light ties the distance of what 3,000 kilometer, 3 kilometer, yes, 3 into 10 to power, yeah, I think million six, and so 1 second means that distance, right? The speed of light is 3 into 10 to power 8 meter per second. Uh, so this and then so anything happens in time should be reflected in space, and space and time. That's. But what itself is a time, right? Um, so the modern understanding is that uh, the modern understanding is that let me read out a couple of questions. Uh, Anjali Kumari, hello sir, hello Anjali. Anjali Kumari further says, "Sir, मेरी job कब लगेगी?" Okay, you're asking about your job. Probably you thought I am astrologer. um, yeah, we know we were talking about just fun part. Uh, there's might be a slightly difference between astrologer and astronomer. Astrologer can tell. I don't know. They say that they can predict the future based on the. But I well Anjali Kumari ji, I have no power to predict your future. I hope that you will soon get your job. Um so that's the part. Okay, some questions. Dishant Maharjan further says, I have been rather interested in high energy astrophysics as well, and was reading about Asian outflows. Yes. And how does Asian outflow jets affect galaxy evolutions? Yes, that is one of the most important this topics. The jet can disrupt the galaxy, but on the other hand, the dust and things around uh, s- shapes the galaxy. The question would be, how does that affect the evolution? Yes. And further, he says, does galaxy evolution always depend on Asian? Yes, in some sense. I will come back to you later. But let me go back to some of the questions. Aman Gupta says, what is the scope of astrophysicist in Nepal? This is a bit hard question. I don't want to be a pessimistic, but given the political situation in Nepal, that doesn't seem to be very encouraging, but again, I don't want to be pessimistic. There are still people like Surisi who are working. They're working hard to do something. Uh, um, but if given a good political, politics is at the base of everything. Yes, if we have a good governments, good government stables, we have a very high potential. We can have detectors in those the tall mountains, or the hills. This is perfect, and Nepal has one of the best weather. We can have detectors, and it could be a kind of hub for the detectors. I was also trying back in some time, but as I found that it's really difficult to go through the administration or the government system. That was but there I would like to say that there are some people, dedicated people, trying to work hard, and I hope that things will get better. So that is answer to Aman Gupta. B says, sir, does astrophysics cover topics from string theory? Since string theory ranges from quantum mechanics to general relativity, just got curious to know. Uh, um, this is very important again question. The string theory comes the is well, the question is a philosophic. You can say that the question is philosophical. Yes. So what is the question? That what is the universe made up of? Is there a tiniest particle, indivisible? We heard about Daltons and then Rutherfords and Bohrs. And what our hope is that you can take an image and experiment, like imaginary experiment, thought experiment. That what happens if you take an apple and you take a knife. It's a thought experiment. You cut it into half and cut into half and cut. You'll become the apple will be smaller and smaller and smaller and smaller. It's again thought experiment. Okay, and you cut it. Um, does a point come where you no longer can divide that smallest thing? Yeah, that is a question. Yes, of course, knife itself is a big thing where you can do that, but it's just thought and experiment. Is there any or in modern technologies you can zoom in, a screen, zoom in the universe. Will there come a point where it will appear pixelated, right? The universe pixelated. Uh, in the meantime, Pradeep says, "Hello, sir. Hello, Pradeep ji. So this is so. What is the nature of the fundamental particle, fundamental indivisible particle? Yeah. So we found what electrons, we found protons, and then we said proton is not a fundamental particle. We wanted to quark, right? Um, and say that this is a fundamental. So there's something standard uh, um, uh, model for particle physics where the quark is one of the fundamental particles. Now, the problem is that there's inconsistency between. Well, there are two successful theories, current theories. Yes, quantum mechanics, which explains about the smallest of smallest, and general relativity, which is like biggest, like, right. uh, um, how do we find a connection between them? Um, this is the kind of challenge these days. So basically, quantum gravity, yes, and then the role of string theory comes from there. And let me go back to the question. What is the question? Uh, String theory ranges from quantum mechanics. Yes, yes. So yes, the string theory. So string theory is basic particle is not a particle. Yes, it's a basic string. In very rough terms, what string theory says is the fundamental particle is not a particle like quarks or electron. It's a kind of strings and whose mode of vibrations mm, uh, materialize as different kinds of particles. That's a very rough definition of string theory. Yes, the persuasion of string theory is basically try to unify these two big fields, very successful and current modern physics. General relativity, the biggest of biggest, and the smallest, the quantum mechanics. So yes, That's the string theory part. Samundra Pathak says, "Sir, is computational a safe career path in upcoming future?" Oh yes, this is one of the safe career because everything is computational these days. Nowhere which part you go. Astrophysics, astronomy requires a lot of computation, machine learning, AIs, building models of universe or the stars or anything. Yes, I would like to say this is a very safe career, and then you get to know about computers. You get to know about physics. You get to know about astrophysics. That's very good. Yes, that would be answer to Samundra Patak. Sribin says, "Sir, when we get information from quantum entanglement, won't it be faster than the speed of light?" Well, yes, of course. This is the idea behind the quantum entangle. The idea is that once a system gets entangled, then no matter how far they are, uh, 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 disturbing one system will be uh, affects to another system very far away, and this is how the signal or information can travel faster than light. Yes, that's the idea. Uh, yes, in some sense, it will be faster than light, but I think this most of the main part of work is actually still being worked out. The details. Yes, of course. If that is the case, and there was a big debate actually, if you go historically, something called EPR paradox. If you have heard about it, the full EPR is this three scientists, Pedosky, Rosen paradox, this kind of thing, and this is yes, the details are being worked out, and this is very exciting part of the quantum mechanics. That would be the answer to Sribin. And let me read out to other questions. Satish Regni, sir, what might be criteria for getting scholarship in aerospace space engineering in USA? I'm in class 12 right now. Will my board exam affect in the scholarship in this procedure? All right. So this is how to get undergrad. I so you are still in class 12. That means you want to go USA for your undergrad. Yes. Uh, I would like to suggest to you that one thing very important. Uh, Try to get scholarship because the undergrad education in USA is very expensive. Their education system is I don't know how it works. Um, it's very expensive. They have to take a loan like costs 300 400,000 for entire period, and very difficult. Yeah. So I would say that if you have plans to go to USA to do your undergrad, um, if you try to obtain a scholarship, yes, to have a scholarship, you should have a good SAT. Yes, that's important. Once you have a good SAT grades, then you apply, and once you get the scholarship, go there. Otherwise, I wouldn't. Well, if you're rich, of course you go. Yeah. Um, but again, the education system is there very expensive. But saying that, this is one of the best places to go for education. I hope I my board exam effect in this scholarship procedure. They mainly care for SAT. Of course, I mean it usually doesn't have that. Your 12 grade is not so good, and your SAT is very good. This is not quite possible. Yes, so if you're good in one, it's highly chances that you're good in both. So whatever you are doing right now, try to get the good grades. Of course, having said that, I told you that there's not much relation between these courses, but it doesn't happen that you have a not so good grade in 12 and then you have very good grade in SAT. It's not possible. So but yeah, so pay attention to your study. I think I'm sure you can get a good grades. And then SAT is very important. And you have once you have a very good SAT, then you can apply. Uh, so it's safer to have a scholarship and go there study. That is the answer to Satish Regmi. Yeah, again, Pradeep G says, hello, sir. Hello. Pradeep Satish Regmi. Sir, can you look comment of mine? Satish Regmi. Sure. Okay. Before we go, I go to Academia Prodigy. I see lots of questions about aerospace engineering. Can we make us clear what is the chance of getting job as an astronautical engineer in space companies as various security reasons are connected? Well, I see lots of prospects, right, in space engineering. Tomorrow uh, there'll be hotel, yes, there'll be recreational stuff in space. There's a security thing. Space is the future, okay, so don't worry, your job, you will get the job, because that is the future. Again, now I will come to like to Satish Regmi, sir. How can we connect astronomy and aerospace engineering in masters or higher study? Should we do dual degree in masters? Well, it happens that if you go to masters and further higher study, you specialize, becomes your field becomes narrower and narrower and very specific. So you don't need to do dual degree in masters. You don't have to do that. But I think if you start your aerospace, in some course you'll have to learn about astronomy. I don't think you need to worry about like how do I combine astronomy with aerospace. Once you take course, they will offer you this course, and as part, and then you can take this course, and then remember, you don't have to do master, because as you have masters and PhD further, your field becomes narrow and narrow and specific. That's how you become an expert. Yes, you small field. Yeah, you do not need dual degrees. For the question, if I can't get to USA in undergraduate, what can I do? I should aerospace engineering in Pulsok or Nepal. My suggestion is that if you want to go to USA and want to have a degree in technical field like aerospace engineering or astrophysics, astronomy, um, these are the subjects they require a lot of time. Okay, so usually in USA, what happens that okay, you, if you don't have scholarship, you will have to work. Yes, you have to go. Your time will be divided between work and study, and that may not be so good for your education. Yes, because you work day and you get tired at night, or if you work at night, you get tired. You don't have time for classes. So that's why I'm saying scholarship. If you have scholarship, then you don't have to work. You can fully devote your time in your coursework. So that's how I'm pointing to. So if you can't get USA in undergrad, yes, you can do also in Nepal, Pulchok, and then apply for masters or further engineering. That you can do. You get masters in engineering also, and in the masters in offer. If you compare between uh, um, undergrads and grad, there are larger number of scholarships in master program. So yeah, you can do that, and then you have to do GRE, TOEFL, and then you can get scholarship. Yes, that I would suggest to you. Okay, then Sribin, sir, if information from quantum entangle is faster than speed of light, won't it violate the principle? Yes, yes, of course. If this happens, this will violate the principle of relativity, which says that the information can't propagate faster than light, which is fixed. Uh, um, But the physics and our understanding of the universe is still in progress. Yes, we have not fully understood everything uh, um, about the universe and the laws it follows. uh, yes, they can kind of apparently contradict each other, uh, but things have been worked out, and but it's possible that there are higher dimensions. Yes, and these laws may not be applied. uh, so these are all physics in future. All right. Engineers Dan, sir. Yes, engineers Dan. Ji, hello. Pusparaj Acharya says, my sincere thanks for your passionate answer to the youngsters. Would you please specify about research methodology that we can adopt at undergraduate level in South Asian regions? Uh, Thank you for your questions, Pusparaj Acharya ji. Um, uh, so, um, yeah, I mean, I also explained it in response to your previous questions. Um, if you want to, well, the first thing, research is very important. Research is for our survival. For any country to prosper, we need research, and some of the countries lacking in South Asia is that they don't have research resources enough. But we need to get to that. Yes. So for undergraduate people, our youngsters, to get into research, uh, again, we must have the culture of reading papers and conducting analysis and play data, computational, and kind of the way of writing papers, uh, things like overleaf, kind of thing. And the computational is one of the most important thing part of the research these days. Uh, uh, the your question is specify about research methodology. Well, it will depend upon what specifically you're talking about. Um, if you talk about in general, it's there's a data somewhere, some kind of, and you process that data. You have analysis tools, techniques, methods, and you get some conclusion, the results, and then you interpret in terms of the existing models. What are the theories around this kind of things there? This is a very um, general framework for research. Uh, but because I come from the science and the astronomy, astrophysics, so in our field there are dedicated instruments, right, to study about certain phenomena in the universe, um, certain aspect of the universe, and we use those data. We use computational methods, including machine learning and AI, and then we look into try to get understand the data and try to get some result, and try to interpret that which theory is correct, or this is in general. um, if you talk about these South Asian regions, yeah, this is th- this is something has to do our regions, because uh, research is not prioritized in these countries. Yes, we have other problems, right? Our political systems, job unemployment and other things, social inequalities. These dominate the science and research, which would be fundamental to a progress of a country. Unfortunately, these are the scenarios in those regions. Okay, I'd like to move on. Blaste. He or she says, I'm not sure if I can see. What are your probably your thoughts on the Fermi paradox? Interesting, very very interesting thing. So first let me explain what is Fermi paradox. Yes, so the Fermi paradox is basically, where is everybody? Meaning, the universe is, 13, nearly 14 billion years ago, old, right? And it's pretty big, like, uh, and that's of lots of materials. There's hydrogen, carbon, and super in this, the heavier elements are cooked into the supernova, right? uh, the star explosions, these things. So, um, we have lots of material lying around our universe, yet we're looking for the aliens. Let's not say alien, any other forms of life. So the question is, are there any other forms of life in any part of the universe? And to answer the question, so far we haven't found, right? uh, uh, but there should be. Why? Because the universe is big and is fairly old. For life you need basically oxygen, carbon, water, and we have plenty of them. So why don't we see the detect the life? And for that, the Fermi paradox is a couple of, uh, uh, assumptions reason that, there could be some of these factors. Because of that, uh, uh, they, the life could not evolve, or they were there and then they're gone. So one of my favorite is that, an intelligent, form of life, ultimately tends to destroy themselves. That's one of the foreign paradoxes. Uh, so you see that we have, enough nuclear power these days to destroy the whole Earth. So if you ask why we can't see life, where is everybody? So one of the thing is that, well, they did. Why? Because they were intelligent, and then. Um, your question, what do you think of, foreign paradox? Well, why there's no life? Well, we're still looking for. Our technology is barely 50, 60 years old. The city is project is dedicated. How old? It started in 70s, uh, and then, um, and you know that, we are sending messages to possible aliens, saying our details, we live here, means are like that, women's are like that, blah blah blah, all kind of our civilization. This is our home. This the some signal kind of sent being sent, uh, 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 but how far the signal traveled? They barely, how big is our galaxy? um, it's, thousands, 100 to exactly forget the number. So it will take some time. So the question, why if we haven't found the, animal or life, and not animal life in, well, we do not seem to have found anything within our, solar system. But I think our technology, it's not so old, so probably we'll find in future. Let's you want to see, aliens, or you don't want to see? This is a big problem. Yes. Anyway, let me move ahead. And engineer student, I am an undergraduate electronics communication and information engineer. I have deep interest in space science and robotics. What can I do? And suggest some roadmap for space robotics. Uh, Good question, engineer student. And what you plan, what you want to dream to be is very good. Again, in future, this is space robot, uh, um, informatics. This will be dominant in future. What you should do, uh, right now, I assume you're studying 12th grade, or high schooler. um, yeah, you have to, so again, the path, the roadmap is, you do your undergrad, with major in electronics, informatics, and you go to abroad, because, in Nepal there may not be many, uh, opportunities. I hope, I guess. Sorry. Uh, so try to do undergrad or have a good score in a city again, as I mentioned earlier, and try to go abroad and take the subject and do well, and then further masters, and then this is a very uh, general, broad roadmap. um, yeah, do your studies and try to get a good SAT, try to get scholarship for abroad, and do the subject. Okay, I'll move again. Your question: I want to dive into space robotics and make projects and prototypes that may help in exploration or maybe enhance the people perception towards astronomy and uh, space science. Yes, um, soon we will send robots in space, of course, uh, because the robot can sustain. They can work into human unfriendly environments as well. So lots of people are working on this. Boston Robotic Group is one of the famous in the world. They're experimenting. Besides in Europe, also there are many institutions working on this kind of things. Basically, you have to join them. Yes, try to find the school, correct school, the right schools, and try to find. And once you're done with the studies, you have to go try find get the job in those companies, and they'll teach you everything. And of course, I mean, this will also widen the astronomy side, um, perception of the side. All right, engineer student is what can be the basic infrastructure for development of space and science and space robotics. Um, Again, as I said, you have to get into studies first, from the point of view the roadmap. Um, But if you are asking basic infrastructure for development, I mean, if you, in terms of establishing company, I may not be the right person to say the specifics. Of course, it's too technical thing. Yeah, if you're planning to establish some company or something like that, develop the infrastructures. I think I would say first join the course, go abroad, take the courses, and learn it from the companies which have already been doing this kind of similar work. All right, moving ahead, ninjas. How many Messier objects have been discovered until now? Well, I'm not right. I am not sure what your question says. The Messier object. You know who the Messier is? It was one of the astronomer. I forgot the dates 200 years ago. Carl Messier. I forgot his name. Uh, what he was trying to do was he was trying to, as I think I forgot most of the details, but what this person was trying to Messier was Charles Messier. His name, I think. And I'm sorry if I think, yeah. So the important topic at the time was the study of comet. Okay, they wanted to study the comet or planets, but these Messier objects at the time looked like nebula. Right? What is nebula? A large collection of dust and gas. Like Orion Nebula. If you've seen the Orion Nebula, which is like protostar. We can be a protostar. That can be a nursery. Star factories could be. Okay. Uh, then so at that time at that time the understanding was that our galaxy is the only galaxy, only universe. So there are no other galaxies. Our galaxy is all the universe, everything. They didn't know about the extra galactic like Andromeda, uh, and they were seeing these blots of lights which are actually the extra galactic objects, the galaxies outside our galaxies. And then he thought, okay, let's because they were studying comets. First, let's try to get rid of this thing, this nebula thing, uh, and so let's study them, so that they don't interfere our work. And he made that catalog, and which is famously known as Messier catalog. Uh, how many objects had been discovered? I don't know the number, but I am not sure what your question is. How many objects have been discovered until now? he cataloged, he looked into the sky, and and he cataloged the things that would disturb him or interfere his work, and he made a catalog. I can't remember out of top of my head how many sources there were, but there were a number of sources. But I don't quite understand your question. What do you mean by how many have been discovered until now? uh, yeah, yeah, the catalog, they have number, but um, yeah, most of them, I would say. Okay, Blast, I hope I correctly pronounce your name. Do you think there is something that is crucial for life to form that we have not discovered yet, or is the universe like a dark forest where aliens are hiding like animals, sacred to show up? Well, there are a couple of things. I mean, these are more of a what I think, yeah, what my perception is. Also, although the details have been worked out and everybody is looking into this kind of things, yes. Um, so, what is crucial for life? Yes, that's been being um, extensively looked into. How the first cell, how life came into Earth. The scientists have been simulating those conditions, right? Uh, if you roughly look at the past of the Earth, where basically it was very hot and slowly cooled down, and there was water. People are still not sure where the water came from and things like that. But how did the first living being came, or how can a living being come from non-living? Everything was non-living. All of a sudden, how this kind are very extensively studied. If you ask me, what do you think about how? Um, what is there something crucial? There's a special environment, special atmosphere required to bring in life. Um, I may not be able to tell anything because people are working up. Sure, there should be a combination. Yes, otherwise, uh, if life would start in any of the conditions, there were the universe is full of lives, yeah, teeming with lives. And I think it may need some crucial form. And the other part is the universe like a dark forest where aliens are hiding like animals. Well, then we have to look at that. What the modern science or astronomy, astrophysics says. Yeah, the the modern astrophysics, astronomy says that um, we only know 5% of the constituent of the universe. Yes. So you might have heard that 75% is dark energy, 25% is the dark matter, and 5% is what is visible. And f- we haven't detected, oh, excuse me, we know for sure there should be something else, which is called dark matter, which is a wrong name. People, it should be called transparent matter because um, no, we can't see them. It's not dark actually. 25% in terms of energy was it, and 90 and 75 dark energy. Yeah, of which people think is responsible to accelerate the universe. Um, these are unknown. Yeah, and only 5% we know. So what I'm trying to say is, um, our science is barely 2,000 or 3,000 roughly years old. Yes, that's what. And the universe looks much more mysterious than we think. Or some scientists, they said that the universe is much more mysterious than what we can think. Yeah. So are aliens hiding in some universe forest? Well, we only have knowledge of a tiny fraction of the universe. So possibilities, yes, of course, that drives your imagination, and that drives your work, and that's what keeps us alive. Yes, motivation. So far, There's nothing like dark. It says yes and no. Yes, it's all is possible. That is answer to your Blatze and engineer student. Sir, astrology and astronomy related by any chance? Uh, Definitely they are related in some sense because both of them study the positions of the stars and planets. I think they basically, yeah, they call nakshatra, and those are constellations. And the astrologers actually were they predicted the eclipses and those things, the motion of the Earth around the background of the different constellations. Yes. So in that sense, yeah, they are related. Now, the where they differ is that the astrologers say that if given this conditions, if at the birth of your time this planet is there, this planet is there, then your life will be you will be rich, or your wife will hell, or you'll earn a lot of money, otherwise not this. So this may not have a sound foundations, I mean, right. uh, so then so basically they're trying to um, they're related in when to the extent they're studying the positions of the planets and stars. But then astrology say that okay, based on that we can predict future. This may not be quite true, although there's a catch. uh, there is a bigger question, okay, something called whether the universe is deterministic or indeterministic. What that means is, um, I'm sure you know about the Newton's law, right? First law, yeah, first inertia. What does it say? Uh, if something is at rest, so it will be forever at rest, and if something is traveling with a uniform speed, and it will continue to continue to be in steady motion for the end of the time. That's so uniform motion continues uniform motion. Um, and the static thing becomes static thing. That's the Newton's first law. Uh, Now, this is called deterministic science. Okay, so if something is at rest, it will always, to the infinity of time, it will be there. So once you know this is at rest, you always know it is at rest. That is a deterministic approach. Yeah. Similarly, something is traveling with a constant, steady velocity. Then, if you know position at a time at some point, then you can predict to the end of the time. After how many, where it will get in 5 seconds, how far it will get in 2 days, and in 5 years, and then the end of the time. So this is a deterministic approach. Now the question is that um, if we know all the information of the universe at one point of time, like chair or stone, now you can make a universe. Let's say you have all the required information of the universe at one point of time, then you should be able to predict the following evolution of the universe. So this is the deterministic approach, but astrologers are slightly different from that. But this question is there, whether the universe is deterministic or indeterministic, meaning you can exactly predict the universe if you, of course, if you know all the required information at what time. All right, let me move ahead. Uh, Praveen Mahara, are you astrophysicist? Yes, yes, sir. I am an astrophysicist. Then Ninja has. Can you tell about Galilean moon of Jupiter? Uh, he was apparently he was the first one to turn um, a telescope to the heaven. That's how they. The sky was something. that was worshipped, feared, and revered, sacred. So it's heaven, anything up uh, and down, and we are earthly, and heaven is the abode of gods. When they so that's how people mostly believe pre in those uh, uh, pre-Gallian period, mostly, not all. And he was the one who actually turned his telescope for the first time in heavenly objects, let's say moon, uh, and kind of relate that the heaven and earth are more of a similar thing. It's made up of similar stuff. So it was, in that sense, it was very revolutionary. Yes, what he did was actually he united heaven and the earth. Yes. Now, can you tell me about the Galilean moons? And he looked at the four moons of Jupiter. I forgot the details. It's been a long time. Yes, you can find out the information in Google. But that was his main contribution. Yeah, the heaven, the sky, and the earth were treated differently back in time. But he pointed for the first time, pointed our telescope to the heaven and find out that the similar kind of material, the heaven, meaning the planets and moon, and then are made of the similar stuff. Yeah, rest of the details you can find. How many moons, kinds of stuff. That's a unity between astrophysics and quantum mechanics. Uh, this is a good question. Astrophysics usually studies about the astronomical things. Yeah, astronomy meaning the big. It also means a very big, yes, astronomy. Um, Quantum mechanics is studies very small, yeah, tiny. Um, why? Because the nature of quantum mechanics is slightly different. Why it's so different? Because um, in quantum world, excuse me. Okay, sorry. Uh, yeah. So quantum mechanics, how different it is from the macro world is, quantum mechanics studies about the micro world, how it is different. This that you must have heard about the Schrödinger's cat, uncertainty principle and these things, but the fundamental idea is that the quantum mechanics is where the observers affects the reality, meaning making observation will change the outcome. Um, in more scientific language, if you want to study the position of an electron, you have to send an electromagnetic wave. Yes, that will tell what is the position. That's how we measure the position and think other properties of electron. But what if the electron and the photon, the electromagnetic wave, have a similar energy range? It can change the making observations can change the position and these things like that. So you can have a more of a philosophical, where the observed and observer are related. They're not just either. In the macro world, what is the assumption when you make an experiment? My making an experiment doesn't change the reality. Yes, that's the assumption. We do a pendulum, the famous example. You do pendulum example, you write there and note down the time. So your action of making notes and making standing there doesn't affect. It's you with pendulum. You want to measure the g, the acceleration due to gravity. It doesn't change that, but in quantum mechanics it does. Um, but on the other hand, astrophysics is like supermassive black holes, galaxies, and they are related in the same in the sense that um, the fundamental things are always at the play. Yes, Um, for example, I don't know if you know these things or the radio. Uh, so whoever knows, please type yes or no. Okay. Uh, it's a question for you guys. If you know what is 20 centimeter radio waves, have you heard about this thing? It's famous. Yes, you have a dish, and you study about the basically the hydrogen extent in universe. You must have 21 centimeter radio wave. Um, do you know anybody or just quick type? Anybody knows what is 20 specifically? I'm saying 21 centimeter radio waves. Does it any know? Okay, no. All right. Um, this is a spin flip, and the spin flip. This is the radiation coming from the spin flip in an atom. Okay, hydrogen spectrum. Yes, the Shantam Maharjan. Yes, S2. Yes, front line. This is a quantum phenomenon. So you're right. Your question was unity between them, right? Um, yes, there is. Yeah. So they are the quantum mechanics at the fundamental level, and this will somehow materialize or manifest in larger universe. Uh, I think that should answer your questions. Um, okay. Further moving further, if we observe uh, astronomy or astrophysics, is there any significance difference between? Plan to do one of these in my undergrad. Okay, the question is what is astronomy and astrophysics difference between? Well, I think I also mentioned previously. Historically, the difference between astronomy and astrophysics is something like geography and geology. Now, what is the difference between them? Geography is a mapping of the world, yes, and geology is like studying, mining and studying how the mountains perform or the oceans and things like that. In the same sense, astronomy is historically again. Now the differences has blurred the definition, the difference between. Uh, Traditionally, astronomy means mapping the sky, yeah, in which part of the sky which is and how it is rotation and things like that. And astronomy is what makes something the for example, astronomy is the distribution of the star, and the astrophysics is what makes star sign, what is this evolution, astrophysics. But in modern days the differences are being blurred. um, you can take up any astronomy or astrophysics. You will end up learning, complementing each other. That's astronaut question. Aka Jason, also known as Jason. If we observe this world at quantum level, everything is a wave. Is it true? Yes, in some sense, yes. um, yes, everything. For example, I'm sitting on my chair. Actually, I'm not sitting in my chair because nothing touches. Um, you see the laptop in my desk. It appears that the laptop is resting on the desk. No, that's not it. In deeper level, there are electrical forces working. Nothing touches anything. Yes, in deeper level, everything is wave. You're right. Good. Let me go further. Aviskar. What career options can we take on this field? I assume you're trying to say in astronomy or astrophysics. Yes, I assume. Um, well, first, what is your interest? Yes. Now, astronomy and astrophysics have grown so big. Yeah. Um, in spite of they're asking the same old questions, how the universe began, what forces are at play, and things like that. Um, but using different instruments, even different techniques, wavelength, it has grown very vast. So it depends upon what specific part you're interested in. That's I would say to Abiskar. This Maharjan hydrogen spectral. Yeah, I was talking about this 21. Aviskar, yes, yes, 20 line, yes. I mean the spin flip thing. Yeah, I told you. For spectroscopic velocity measurements, yes, yes. The something is moving towards you and away. That will produce the Doppler shift, and that will can be analyzed to this part is moving away or towards you. Yeah, I know. Occasion is. I think you're talking about S 24 thing. 21 centimeter radio wave. Yes. What are the assumptions made now? Blood says, what are the assumptions made by quantum mechanics? The ones that are not proved. Hmm. Assumptions. I wouldn't say they're assumptions. Uh, you know. Science cannot rest on assumptions, right? Yeah, there could be some postulates, but not assumptions. Based on assumption, you cannot do science. Anyway, uh, I am not quite sure of your questions. Uh, Assumptions based on quantum mechanics. No, you know the history of quantum mechanics, yes. Uh, by the way, there's an interesting anecdote. Max Planck was a very good pianist. He could play very good piano, and so at his time, um, Newtonian mechanics, Newton, the approach taken by Newton is Newtonian mechanics or physics, could solve most of the problems except for the complexity of large parameters. They could do anything. So at that time, it seemed that you would no require further theoretical physics because it was only how to employ the Newtonian physics at the time it appeared. And he used to play very good piano. So his teacher said, um, "Well, you are a good player. Be a musician. There's no future in physics." And he's the one who uh, explained photoelectricity, or he postulated that to explain black body. Actually, yes. So the horizon of science becomes wider with observations. Yes, not with assumptions. So he's the one who said first time said that there are pockets of packets of energy, quanta of energy, and that's how later it turned out to be quanta. Yes, I don't think there would be any assumptions. Yeah, or may not be. I didn't understand questions. Let me move ahead. How much part of quantum mechanics is just philosophy? Uh, um, you know, the everybody, the people in the field, what they say is, if you talk about, for example, a bit older, um, Feynman, you know, what he says is, if someone say I understand quantum mechanics, then he's lying. That's what he says. Um, understanding quantum mechanics is maybe difficult because we're not used to the workings of the micro level, right? Like how can be a light and be particle and the wave at the same time, right? How can you produce even if there's one, the uh, scattering, how can some single particle can form a interference pattern? These things are non-intuitive, right? um, they are not quite philosophical, but they are difficult to grasp. um, but they are very successful. They're very successful in explaining things. It's just that it doesn't look intuitive for us, like Schrodinger's cat, which is what is he's alive or dead, right? Questions. Um, I don't know if it's philosophical. It's just that something are very unintuitive because we are the living beings of macro world, meaning big, and the on the other hand, it explains the physics of very micro particles like electrons, quarks, and things like that. Okay, um, aka Jason, if universe was began from singularity, when then what about the future of universe? uh, Cosmologists, astrophysicists think there are a couple of trajectory how uh, universe could evolve. Um, excuse me. Uh, Not long ago, um, people thought that option wise, right? The current understanding is that, as you said, the universe began from singularity. You can call it Big Bang, and ever since it's expanding, like an expanding. The question would be, we can think of three trajectory, yeah, evolution of the universe. One in which it will keep on expanding and expanding forever. Yeah. The other thing is it will expand and expand, but after some while, it'll slow down, and maybe, and then it'll stop there, something like that. And the third is that once it stops expanding, it will come back. Yeah. And then it will contract again. Yeah. So oscillatory models, meaning the universe will expand and they will contract, and big there will be anti-big bang, big crunch, uh, and then again from there, the big bang, the universe will expand. So oscillatory method models, yes, this is one of the things. But in 1995, I think. So how do we? The question you ask is how do we know it's expanding? Right, the universe is, how do you know it's expanding? We know from the observations of uh, the brightest objects, which not only the brightest object, but we should be able to tell how far they are, and then this is something type is supernova. Yes, they go boom, and they become very bright. They even sometimes become brighter than a whole galaxy, entire galaxy, and we can see them from far away. And they make up something called distance candles, meaning you can tell how far they are. If you detect um, some supernova, you can tell from their brightness, you can tell how far they are. And in 1970, I think that's the name of the supernova, they kind of estimated that the universe is not only expanding, but it's accelerating. What that means is it is expanding rapidly, meaning it will not come back. It will, again, this is limited understanding. Yes, we have very narrow period of our study. Not, uh, but the current understanding. I'm taking a little bit current understanding. It will forever expand. That's the current accelerating mean that's. So what will happen? Um, so after some time, the galaxies will run apart. Yeah. One thing you have to understand is that if you ask how big is the universe, then we tend to say that it's 13.7 billion light years ago, and so that big. But that's not the right answer, because some part of the universe is you remember, if you go far away and back in time, the thing is traveling faster, and at some point the point of universe will even expand faster than the speed of light. Yes, because that's how the Hubble works. And that part of universe is already detached. What happens if something travels faster than light? It is no longer, we are no in casual acceleration, meaning it is not connected, it's gone for our universe. We have no way to um, so some part of this is gone. So in a rapidly expanding universe, first the galactic clusters, there's a galaxy, there's galactic clusters, and there are even strings, yes, and slowly they will recede away, and they would far away, speed faster than light, and there that will disappear, or they will go away from our visible universe. Yeah, there will be less and less matter in the visible universe. Everything will expand and expand and expand. By the time um, there will be only black holes, The universe was a very very cold place. So very horrible ending, if you look at from this way. But again, we're still in the process of studying those systems. We need to study a lot and find out a lot. That's why we need you. So there's a question for me. Where did you graduate at? I did my PhD from USA, Florida International University in Florida, Miami. That's where I graduated. That's where I got my PhD actually, and then came Europe, in Poland, to do multi-messenger astronomy, and keep on traveling many parts. And although I'm stationed in Poland, so that's what I do. Okay, and we missed the hall. Answered the question. He's professor of, yes, of course. Thank you for answering me. Um, Blatz, do you think we invented science or discovered it? Like we are describing a phenomenon with rules we make because easy have one kind of explanation for a phenomenon that are proved. Um, I think this is more of a philosophical question, right? In some sense, science is supposed to be objective. Yeah. What does that mean? That if um, one thing is true for me, the this same must be true for others, right? That's the meaning of the objectivity. Yeah. Um, you can imagine, if you read about the uh, Hindu mythologies, right? There are different kinds of universe. Yeah, the universe of God. Yeah, the universe of snakes. Yeah, the universe of, you can imagine a universe, demons. Yes, um, many kinds of universe you can imagine. But one thing you cannot imagine: what kind of universe? The universe where 2 plus 2 equals 5. You can imagine the the universe of giant snakes, the universe of water, universe of demons, anything you can. So we can't. So what I'm trying to say is the objectivity is something conveyed by mathematics. Yes, um, but even in mathematics there are some philosophical problems. Yeah, um, the all started with Pythagoras, or simple postulates, uh, um, like a straight line. Yeah, a straight line is a continuation of points, or the what is distance, what is triangle, and things like that. Now philosophically, okay, that's probably. So I think I actually want to discuss these things also in my channel. That um, a straight line is a continuation of points. Yes, a straight line is straight, but where is the straight line in reality? If you want to draw a straight line, can you draw a straight line on a paper? No. Why not? Because on paper there are atoms which are constantly vibrating. Yes, and they are no longer straight line. Yes, because a straight line assumes that there are rigid points. And similarly, um, a circle is a perfectly round thing, right? But if you try to construct one, where is a circle? No, there is no circle in real life. Yes, uh, only the approximations. Yeah. So what people say, what I'm trying to say is that the ideas, these ideas, what we see the world, the universe, is some kind of approximation of some pure ideas. Yes, it's like one is pure one. Yeah, one number. Two, uh, circle, triangles, and they, you may not find the actual manifestation of the things in real life. I sort of went to digress. What was the question again? Yeah, we invented science or discovered it. You know, so science is based on mathematics. mathematics in some sense appear to be very objective, independent of people and their biases, right? Uh, a rope may appear for somebody a rope, a snake for others, with poor eyesight, or depend on in evening or daylight, broad daylight. But the mathematics is mathematics. The sum of triangles is 180. Yeah, this is always true. And slowly you build up the science. You make a triangle, rectangle, right, and then you input the laws. These are only the properties of space, and you say Newton's law, the dynamics and statistics and things like that. You make science. You science. But again, the thing is that it seems that some kind of idea drives the universe. I can go on as long as I want, but this is philosophical part. It is hard to say, but we broadly we discovered science. I wouldn't say it's we invented science because it seems to be there, but there are other philosophical things, of course, which we may some kind discuss. And okay, so let me. So after Blatt's astronaut says, um, "Is it possible for me to study masters in astrophysics after doing bachelor in?" Yeah, you can study. Yeah, of course. I mean, you can masters. Masters, you have to do some course in astrophysics. I mean, that's the requirement. Is I think, but it is still should be possible to do the computational physics or something. It will depend upon what course did you take in bachelor. Um, I think there are some very specific criteria, like how many credits you must have done physics and so on. Mm, I don't know what did you take in your bachelor, but again, computational physics is a big field, right? Um, Making models of the universe, uh, for example, making models of stars, jets, and this require high computational power and skills. So I'm pretty much sure you can pursue if you want master's in industry. You can take it. You can get it. Ricky Rai says, "Big fan. Thank you very much, and hope to connect in future also." Um all right, this kind of things encourage us to to create, and then interactions always inspire. Thank you very much. Samir Sa says, as a high school graduate, taking a gap year and having recently received an admission decision from CU, Boulder, or Colorado, aerospace engineering, I am enthusiastic about the pursuing opportunity. Okay, congratulations, you get accepted in Colorado Boulder. That's a great space to be. That a great university to be. Wish you all the best. Good. Um, that's good for you. Wish you all the best. That's good. Uh, how could a high school graduate student secure internship in aerospace field to boost this profile? Is online internship worth it? I got a chance to explore. Well, uh, for high school, could a high school graduate student secure internship in? I don't know about the internship after high school, uh, but there are some research and training opportunities. Uh, there could be. I am. This is a very specific questions, meaning where do I find the internship in that particular field? Uh, I may not have the authentic answers. So I will leave you for to explore in some other places. Uh, Umesh Dal asked me, can you provide advice for aspiring astronomers on finding research opportunities during graduate study? Oh, graduate studies means research. Okay, uh, you have to do. It is not clear where and what are you studying. Um, in Europe and USA, graduate studies means research. You know that at least some kind of form of thesis, or if you're a PhD, then it's basically. But he's saying, can you provide advice for aspiring on finding research after. Well, this is the place wherever you study. There should be some professors and your teachers, which will uh, provide you these research opportunities. I'm not very much clear what you're trying to say. The university is the place for research, right? That's where you do research. Um, Again, we have a group in Nepal. You can feel free to join them. I am also in them, trying to publish a paper. I was a little bit busy with other stuffs, but I will soon try to finish that project. We're analyzing some X-ray data of agents and blazars and trying to publish. And if you like, you can join them also. All right. Now, moving ahead, that says is a roadmap for eighth grader. That is um, really fascinated by quantum. Oh wow, yeah, of course. I mean, this is the right age. Yes, um, this is how people become inspired and good. I am very happy to say that eighth grader is actually inspired by quantum mechanics. Uh, um, well, in the beginning, you have to do your studies. Mathematics should be good. Mathematics not as a subject, that uh, mathematics as a logic. Yes, if you understand the reasoning and argument, you're good in mathematics. What does that mean? That means you have your reasoning is good. Your sound in logic. Yeah, that's what it actually means. um, so because in quantum mechanics we'll be entering into the micro world, into the universe of unknown, and then the mathematics is the tool. This is our eyes to peer into this micro world. So I would say that keep on studying, get as study as much as mathematics you can, be curious, and then uh, the mathematics traditional uh, the traditional way of teaching mathematics sometimes sounds boring, but there are these days simply so much resources online that makes mathematics so much interesting and fun. um, Try to plot, for example, play with the plots, even starting with sine waves and curves. Python, if not Python, there are online calculators with plot and try to understand the behavior of the curves and this kind of thing, and slowly good grades in mathematics. And from then, there's science, and then these things will follow. All right, that would be my suggestion to an eighth grade, and there's a way to go. I mean, I really like the aspiration of eighth grader who actually wants to do quantum mechanics. All right, astronaut. I am also an high school graduate, and I plan to pursue undergrad in US. Very good. I mean, US again. US is one of the best places to go to school, right? They have best resources, um, education, professors, and but at the same time, as I said, the expenses are really high. They're difficult to. So my own again suggestion: try to good to with your studies and try to get the good SAT and good grades and good SAT. Try to get a scholarship. Then no one can stop you from what you want to be. And my always best wishes always for you. Um, Astronaut Adin says, will there be any opportunities with doing undergrad in astrophysics in here? In here means it's not clear what you're saying. In here, uh, if you're from Nepal, if you're talking Nepal, as there are a couple of including Suresh ji, they're doing trying to do some um, the commendable effort in trying to do astrophysics, astronomy by themselves. I would suggest you to join them. Uh, yeah, yeah. Slowly, I think you'll get there. Undergrad in astrophysics in I don't think there are dedicated institutes like formal training in Nepal. If you're from Nepal, all right. I wanted to just say hello to you. It looks like I spent 2 hours. Well, thank you for your participation. I think. So maybe we will see you next time. Once again, thank you very much for joining. I love you all as a great audience. I mean, so much engaging questions and curious. Uh, so so we'll be in touch. So stay tuned. Uh, I think I tried to answer your questions. Um, Again, uh, please share and subscribe. That as YouTuber, I have to tell you and recommend my channel to your friends. So see you in next uh, live, and I wish you all the best. Bye bye. And Batya says thank you, and Umestal thank you everybody, thank you being Shreya. I'll see you next time. Bye.